Alright, this is homework 1.5. I'll be going over problems 31, 35, 37, 39, 41, and 43. So, what is the difference between a monoprotic acid and a diprotic acid? That's the first part of 31. A monoprotic acid is just an acid with one thing in it, one thing that can be donated. So, HCl is a monoprotic acid. It'll only donate once. It'll donate its H plus. But a diprotic acid like H2SO4, notice how it has two hydrogens here. It'll ionize twice, where you'll just see it go twice. You'll have two hydrogens in solution instead of one. That's the difference. So, like in the reaction, it'll be like H plus HSO4, and then it'll react again to H plus SO4. And these are all ions. So yeah, that's the difference. And then for a weak acid and a strong acid is something that ionizes completely in solution. So for example, HCl is a strong acid. If you put HCl, a sample of HCl, in a solution, literally all of it will become ions. But if you were to put a weak acid, only some of it will, because it does not have a super strong, it has a stronger connection, so it won't want to break up as much as HCl or any other strong acid. So that's the difference. A weak acid doesn't want to break up as much, doesn't want to ionize as much, but it still will ionize, but just not as much. And a strong acid will completely ionize. Everything will be gone. All right, now part C, an acid and a base. So an acid is a proton donor, and a base is a proton acceptor. What I mean by that is that an acid will donate its hydrogen, and a base will accept the hydrogen and give it to its base, and that'll form a water. That's just an example. Not all acids and bases are like that. But for example, HCl and NaOH, the OH and the H will combine to form H2O, where the H will be donated to the OH, and that'll form water. So yeah, that's the difference. Now, 35. Label each of the following substances as an acid, base, salt, or none of the above. Indicate whether the substance exists in an aqueous solution, entirely molecular form, entirely as ions, or a mixture. Let's start with A. Hydrofluoric acid. Hydrofluoric acid is a weak acid. So it is an acid, and since it's a weak acid, it will not entirely be ions. It'll be a mixture. So it is acid and mixture. Acetonitrile. Acetonitrile is none of the above. It's entirely molecules, because it's not an acid, a base, or a salt. It's a covalent compound. NaClO4. So this is a salt. Salts always ionize. Well, not always, but mostly ionize. Like if it's a soluble salt. If it's an insoluble salt, it won't ionize. But since it is, we will consider it a salt that is entirely ions. Now, for BaOH2, this is on the list of your strong bases. So this will be a base, and it'll be entirely ions because all of it will break up. So yeah, that's 31 and 35. Alright, 37. Classify each of the following substances as non-electrolyte, weak electrolyte, or strong electrolyte. So to clarify, a electrolyte is something that ionizes well and conducts electricity well. So we want to see things that ionize. Alright, first with H2SO3. H2SO3 is an acid, but is a weak acid, so we consider it a weak electrolyte. Ethanol is neither an acid nor a base, and neither is it a ionic compound. So it is a covalent compound, and covalent compounds are not electrolytes, so it's a non-electrolyte. With NH3, NH3 is a pretty common weak base, so it's a weak electrolyte. Then with copper nitrate and potassium chloride, they're both ionic compounds that are soluble, so we consider them both strong electrolytes, because ionic compounds that are soluble love to be soluble and love to ionize, so we consider them strong electrolytes. Then for 39, I will only be doing part A. 39 is just asking you to make the molecular equations and then the net ionic equations. So for the molecular equation, it's just calcium plus bromine plus 2 waters, and then you can see the balancing here. And then for the net ionic equation, this is kind of important. The only things that are interacting here are the hydrogens and the OHs. So this is the net ionic equation. It's just the hydrogen reacting with the OHs. And yeah, that's all. Alright, 41. Write balanced molecular and net ionic equations for these reactions. I'll only be doing A. So with A, it's just saying solid cadmium sulfide and sulfuric acid. So to get your products from that, and then eventually an ionic equation, you're just going to combine your ions. So the cadmium and the sulfate will come together from cadmium sulfate because they're from different products. And then the hydrogen and the sulfate will come together to form hydrogen sulfide. And then to make your net ionic equation, it's just going to be The only thing that you're removing, the only spectator ion, is going to be sulfate. And you may be thinking, why isn't cadmium a spectator ion? It's because cadmium is going from a solid to liquid state, and that is something that you have to consider because that is a change in the actual substance. So you include that in your net ionic equation. Now, 43. So this is just going to give you a bunch of random chemicals, and it's going to ask you to make the net ionic and molecular equation. So I've put a PNG of all of the equations, and that is the answer to part A, because I did not want to write all of them out. Now for B, by observing the reactions part A, could you distinguish any of the three substances from the other two? So yes, you can, because, and this is kind of a arbitrary answer, but yes, you can, because in the magnesium carbon or carbonate reaction, carbon dioxide is produced, and that makes it bubbly. That gives you a very volatile experiment. So you could distinguish the reactions because the magnesium carbonate one makes a kind of a messy reaction. So yeah, yes, you can. And then for C, if excess HCl is added, would the clear solutions left behind after this reaction complete contain the same or different ions? So if excess hydrochloric acid is added in each case, the identity of the ions is the clear product solution is the same. Each different reaction produces magnesium ions along with chloride ions, and there will be H plus and more chloride ions from the excess acid. So yeah, that's it. All right, have a good night, and hopefully this helped you out. Again, if you need any help, don't be afraid to ask me or anybody else who's taken AP Chem before. And yeah.